Download this code from codegive.com, link in the description below. Gradient descent optimization, a comprehensive tutorial. Gradient descent is an optimization algorithm used to minimize the cost function in machine learning and machine learning models. It is particularly useful in training neural networks and other machine learning algorithms. What is gradient descent? Gradient descent is an iterative optimization algorithm that adjusts the parameters of a model to minimize the error, or cost. The algorithm works by calculating the gradient, or derivative, of the cost function with respect to the model parameters. It then updates the parameters in the direction that reduces the cost. The learning rate. The learning rate is a hyperparameter that controls how much to change the model parameters in response to the estimated gradient. It determines the step size during the optimization process. Too small a learning rate, the convergence will be slow, requiring more iterations to reach the minimum. Too large a learning rate, the algorithm may overshoot the minimum and fail to converge, or it may oscillate around the minimum without settling. Formula. The update rule for gradient descent can be expressed mathematically as follows. Backslash theta underscore new equals backslash theta underscore old, backslash alpha backslash dot backslash nabla backslash theta. Where backslash theta represents the model parameters, weights. Backslash alpha is the learning rate. Backslash nabla theta is the gradient of the cost function with respect to the parameters. Example, linear regression with gradient descent. Let's implement a simple linear regression model using gradient descent. Step 1, import libraries. Python. Import numpy as np. Import matplotlib.pyplot as plt. Step 2, generate sample data. Python. Generate some sample data. np.random.seed, 0. X equals 2 asterisk np.random.rand, 100, 1. Y equals 4 plus 3 asterisk x plus np.random.ran, 100, 1. Y equals 4 plus 3x plus noise. Step 3, define the cost function. The cost function for linear regression is the mean squared error, MSE. J theta equals frac 1 m sum underscore I equals 1 caret m, h underscore theta, x caret I, y caret I, caret 2. Where h underscore theta, x, equals theta underscore 0 plus theta underscore 1 x Python. Def compute underscore cost, x, y, theta. M equals len, y. Predictions equals x dot dot, theta. Cost equals, 1 slash, 2 asterisk m, asterisk np dot sum, np dot square, predictions, y. Return cost. Step 4, implement gradient descent. Python. Def gradient underscore descent, x, y, theta, alpha, iterations. M equals len, y. Cost underscore history equals np dot zeros, iterations. For I in range, iterations. Predictions equals x dot dot, theta. Errors equals predictions, y. Gradients equals, 1 slash m, asterisk x dot t dot dot, errors. Theta dash equals alpha asterisk gradients. Cost underscore history I equals compute underscore cost, x, y, theta. Return theta, cost underscore history. Step 5, Prepare data and run gradient descent. Python. Add bias term, intercept, to the input features. x_b equals np.c_np.ones, x.shape 0, 1, x add x0 equals 1 to each instance. Initialize parameters. Theta_initial equals np.random.rand, 2, 1. Alpha equals 0.1 learning rate. Iterations equals 1000. Run gradient descent. Theta_final, cost_history equals gradient_descent, x_b, y, theta_initial, alpha, iterations. Step 6, visualize the results. Python. Plot the cost function history. plt.plot, cost_history. plt.slabel, iterations. plt.elabel, cost. plt.title, cost function history. plt.show. Plot the linear regression line. plt.scatter, x, y. plt.plot, x, x_b. Theta_final, color equals red, line width equals 2. plt.slabel, x. plt.elabel, y. plt.title, linear regression result. plt.show. Print, f final parameters, theta_final.ravel. Explanation of the code. 1. Data generation, we create synthetic data points for a linear regression problem. 2. Cost function, the function compute_cost calculates the mean squared error between the predictions and the actual values. 3. Gradient descent implementation, the gradient_descent function iteratively updates the parameters, theta, based on the computed gradients and the learning rate. 4. Visualization, we plot the cost function over iterations to observe the convergence and visualize the fitted linear regression line. Conclusion. Gradient descent is a powerful optimization technique widely used in machine learning. Understanding how to choose the learning rate and implement gradient descent is crucial for training models effectively. This tutorial provided a basic example using linear regression, but gradient descent can be applied to various other algorithms and models as well.